All right, well, I guess we can get started then.
Okay.
So yeah, I mean, I understand your background is molecular biology, and you work in biotech, and you had some health-related issues yourself with
Yeah,
autoimmune,
it's
and
it's it's a long story because it started out. Initially, I actually worked in healthcare,
oh, okay,
but I was kind of a salesperson for surgical devices, so it was not like working in the actual taking care of people of patients. So
gotcha.
I've never had a patient, to be honest. So this part is only what I learned from my friends, medical doctors and others. So
Gotcha.
yeah, and then I moved to industrial biotech. I worked for an enzyme company for something like 9 years, and I was first. I did some technical sales, selling enzymes to different food industry, ethanol production, including bioethanol, and then the main part was starch processing, which means high fructose corn syrup,
Hmm.
basically. So I'm an international expert of fructose syrup
Wow.
production, and yeah, all this kind. And then lately, I worked for a local syrup producer as a application support specialist, which is basically providing technical support for the sales staff. So visiting food industry customers and explaining how to use, how to switch products, and how to formulate different things. So this kind of and all the health stuff is completely a hobby so
Gotcha.
far.
Well, we like your hobby. I think I've been following your work for probably a year now, and you always have very interesting papers that you post on Twitter and some very insightful
Yeah,
comments. So I
I
always,
started as a yeah, it started as a regular weight loss journey, something like a little bit short of 6 years ago,
wow,
and then I very quickly lost something like what it's in pounds, 70 pounds
wow,
in 5, 6 months,
impressive.
and then I was already running some experiments because I couldn't believe it. I'm officially a biologist, so I'm supposed to understand how things work, but actually I didn't, which turned out that I had 3 meals a day. I started out a regular uh, kind of Atkins, and then moved to low carb, high fat, and I was really amazed by the high fat part. So I started adding in between my 3 meals buttered Brazil nuts. Brazil nut is something like 90% fat,
Hmm.
and butter is 82% fat. And I was really curious if that would stop my weight loss, but it didn't.
Wow.
So I was amazed. It was not really pleasant because I had these heat waves in the evenings when going to
Right.
bed. My body still tried to burn off the stuff, the extra calories,
That's very
and it
interesting.
was not very pleasant. I had these heavy heartbeats, and I was sweating in the bed, but otherwise I was fine, and I was still losing weight, which was quite amazing. And I still don't fully understand how this stuff works, and
I don't think
I think that
I don't think
what
anyone does.
keeps.
I think I certainly appreciate that you can admit that. I think anyone who claims that they know how it all works is
Yeah,
needs
I
to.
have I have a very long list of reading stuff. I have something like I'm closing on 8K papers in my library,
Wow.
and yeah, I have something like I usually run into the max limit. That's how I actually found out the max limit of my iPad Safari tabs, because suddenly there was this a little bit blue cross was grayed out, and
Oh
I
no.
was like, what the hell? And I recognized that I reached the maximum tabs. That was 499, so I was not
Wow.
able to add the 500th tab. So then now every month I get rid of 100 tabs, and then within a month I just add 100 more. So I have to do this cleaning again and again. It's
That's
crazy.
crazy.
So I have one feature for Apple to add to the Stack browser that somehow I should be able to export at least the title and then the web link for the tabs.
That would be
because
nice.
then I can save it in a much easier way than just saving it, adding to the reading list by one. It's crazy.
Right.
You can do that with 400 tabs.
That's a little crazy. So you've evidently done a ton of reading, and you share a ton of it on Twitter, and that's
yeah.
been a really
I
great source
preferably I call myself a sofa researcher because that's what I do. I use my iPad mainly as my primary device because it's great for reading, especially these colorful and large screen stuff. It's not really good. It's not ideal to use a small ebook reader or whatever. So I've been using an iPad for, I don't know, more than 8 years.
Nice.
And then obviously almost 6 years for reading papers. And these days, I think I almost exclusively read papers and no blogs, very rarely some videos and these kind of things. I have such a long list of to-dos in terms of papers that I'm really feel that it's a waste of time to go and read blogs and these kind of things and books and whatever.
Fair enough.
So I really apologize if somebody is listening to this and he finds out that I won't necessarily read his latest book or blog post or whatever. But when you are deeply into the intestines, then
I think you're
then
doing the important work here. I think somebody has to
yeah,
go read all the
that
source
is very,
literature.
very difficult to go and do some light reading.
Yep.
So yeah, I do it in my free time mainly, obviously, as a hobby.
Same here. Yeah.
Some
I guess we both got the day jobs.
Yeah, some areas overlap with my day job. For example, the fructose part. You saw my report. I have another one more recently completed on the differences in metabolic and health differences between sugar, high fructose corn syrup, and honey. There are actually no differences, but that comes from the basic chemistry. So, but you have to explain it to people because they don't want to. People, what I recognize, for example, on Twitter, people love to hear something which they have some kind of a bias.
Exactly.
Or they have a belief, and I recognize very often that I post something, and you can predict if it is going to be popular or not. If it's something not overlapping, not overlapping with the major biases or expectations, then and it's very deeply scientific, you get something like 5 to 10 likes. If you share something which overlaps with some of the groups, low carb or whatever groups basic ideas, then you get 100 retweets and then I don't know 300 likes and 30k impressions. And
that's very funny.
Now you can I'm able to predict more or less with high accuracy if it's going to be a popular or just a nerd post.
That's a little scary. I think people need to make sure that they're pursuing their own biases, and as Feynman says, you're the easy person to fool.
The funny thing is that you just post something which you believe is very important, and it's a great addition to our existing knowledge, and then I keep adding replies, like creating a thread, and keep adding replies, and even with the I don't know how many replies, it's got only 30 likes or whatever. So I cannot really make it appear more important than people believe it to be. So it's rather difficult. But
so with all this reading, what would you say your kind of running hypothesis is right now for the cause of chronic disease?
The funny thing is that
related,
it constantly changes, and this is you'd like to hear my wife when I say something that you shouldn't eat that, or you should change that in your daily habit or whatever. No, it's completely different what you were saying 2 years ago, even compared to last year. It's crazy. I'm fed up with all this. So
I think that's great that you're constantly refining your opinion, and I hope that I can do the same, and I have been now. But I'd be curious to hear, just like at the moment, what's your point in time snapshot hypothesis of with the latest information you have?
I'm still hovering between two pathways or two possible etiologies or two common metabolic diseases, and One is what seems to work in rodents, in murine and rat and other models, so that they start to eat this so-called high-fat diet, and then their gut becomes leaky. They see all these high amounts of lipopolysaccharides entering their, usually not the bloodstream, but this is a different story we will come back to, I guess. And there was another paper in Nature which describes a very similar pathway, but then it's chronic colonic acetate, which makes to their bloodstream, and somehow the brain perceives its chronic elevation in blood acetate as probably a chronic dysbiosis in their large bowels, and then it creates an inflammatory response, which includes the hyperinsulinemia, and then hyperinsulinemia stimulates all the hyperphagia, which is the overeating, and the downstream effects, what we recognize as metabolic disease, and including obesity. So this is very compelling, but I'm not sure actually that it works the very same way in humans. So there is another possibility I see, and there are some studies which point to it starts very similarly with imbalance in the small intestines. And if you saw my presentation, my talk in Prague, where I described this imbalance in connection with the hormones, the hormonal imbalance.
Secretory hormones, the GLP-1
yeah,
and GLP-2,
and then it can be connected also to a changed inflammatory response, and all this can create a kind of a adipose tissue chronic expansion signal. And that requires actually stimulation from lipopolysaccharides for opening up the gut barrier, so that it's actually part of the healthy adipose tissue expansion. So in order for the tissue to be able to add new blood vessels and all the matrix, all the cells, what's needed for expansion, you need some kind of a local inflammation. And it seems that the body cannot just create the necessary inflammation out of nothing, but it opens up the intestinal barrier, and the delivered bacterial debris or even cells create the necessary inflammation for expansion.
Interesting. So there's the possibility of like reverse causation kind of thing.
There is this Swiss guy sitting at the University of Texas, the Touchstone Diabetes Center. Is called Scherer. He's from Switzerland, and he's now I think he's now the director of this the whole institute, the Diabetes Center in Houston. And I think he got the Banting medal something like 2 years ago.
Wow.
But never mind. The important thing is that his group was the one showing this, that you need the inflammation in adipose tissue in order for the healthy expansion. And the way the body could do that was opening up the barrier. So the question is, the typical chicken and egg, which occurs first, is the opening up or disruption of the barrier, which causes all the downstream effects, or there is a chronic stimulation for expansion, which opens up the barrier to create the necessary inflammation. So in this regard, I'm really undecided.
So I guess following on from that, is there an experiment you could come up with that would offer insight into which of those is likely to be the case? Is there something?
I think there are so many details. I'm up to my nose deep into this right now, trying to find out how it happens in at least mice, and then trying to find similar information in humans. It's really unfortunate, but at least we have something that much of the information comes from these rodent models. So what is translatable, what is applicable to humans is always a big question mark.
I hadn't thought about the possibility of the reverse causation yet, but it's interesting. Like the research that I was looking at was feeding high-fat meals. I'm sure you've seen this study where they gave high-fat meals to diabetics, pre-diabetics, and normal controls. We'll call them normal controls because we know that the U.S. population is a gosh darn mess when it comes to metabolic health, and who knows if these people were really healthy or not.
Yeah.
So Nick and I want to retry this with having a couple carnivores as controls, because we'll assume that somebody who's a lean zero carb eater is going to have reduced.
Yeah, but they have a physiological insulin resistance, and then it's another kind of disturbing parameter. What you will find that they have, if you feed them glucose, then it takes ages to.
Right. Yeah. That makes sense.
It takes ages due to the circulating ketones and fatty acids. It takes ages for them to clear the glucose.
Yep. So this would be a high-fat feeding challenge. So we would use heavy cream, and that's what they used in this study. And they looked at postprandial.
Cream is already interesting stuff, because cream in rodents won't create any problems. So
interesting.
If you feed them a high cream diet, we have, and it was replicated in humans. Actually, I have something like 3 studies saved, and I still remember I saved them with tagging by WT%, because one of the studies contains in the title the weight percent. And then this is how I remember these studies. I have them saved, and when you feed rodents with a high dairy fat diet, they don't become obese and diabetic. So
interesting. Well, I assume that's true of humans if you remove all of the other stuff. I guess in this case, the diabetics may have had, and the normal weight controls could have eaten some McDonald's and some gluten and some whatever else beforehand. So we have no idea like what the state of their gut is to begin with.
Think,
but
in rodents, you need you need the disruption at the intestinal barrier.
Right.
So that it seems that dairy fat rather reinforces barrier function. So it's not a good model for creating diabetic animals.
Right. That makes sense. But in this case, when they did feed the diabetic humans with the dairy fat, they saw that in the 4 hours, as the area under the curve, the diabetics absorbed 336% more endotoxin as compared to
that's
weight controls.
I think it's a long discussion what we should consider as a impaired barrier function, because the basic anatomical and physiological setup in the small intestines is that long chain fatty acids are not absorbed into the blood; they are absorbed into the lymphatics.
Right.
So they go into chylomicrons, and chylomicrons are secreted into the lacteals, which are the primary small vessels of lymphatics, and then the lymphatics is being collected and transferred to the mainly to the mesentery, which is kind of adipose, some lymph nodes hidden in adipose tissue, one of the main visceral fat depots. And actually, I think there is a very good reason why it is kind of designed by nature like this. So lipopolysaccharides attach to long chain fatty acids, and this stuff shouldn't go to the liver directly, but they are kind of being filtered in the mesenteric lymph nodes first, and then it's forwarded to the big lymphatic vessels, which connects to the large vein before it enters the heart. So it gets kind of a bypass from the portal circulation, and then there is a good reason why that works like that. And then so I don't really consider it as a impaired barrier function. So by definition, I think leaky gut means that when you have these tight junctions between cells and they are disrupted and stuff enters between the cells, that's when you have leaky gut. But when you intentionally transfer luminal content, including lipopolysaccharides, into the chylomicrons, that's not leaky gut. That's a normal working of the system. So I think there is still a huge confusion regarding
So I guess
what.
that gets kind of tricky though, because if you had dysbiosis, let's say, of some sort, and you had increases in die-off or in gram-negative bacteria, just increasing the total amount of lipopolysaccharides that could enter when you do have high-fat feeding, one would assume that that's also bad because you're going to exceed the body's capability of dealing with that.
I think that's a reasonable hypothesis, definitely. What I don't really know is what we do know is that simple sugars have a kind of a double whammy on this process. So when you have a regular simple sugar intake, which means simple starches and sugars, then these create the dysbiosis itself. So you will actually it's astonishing how little information is available on small intestinal microbiota. Everybody is doing fecal, but who the shit cares about this literally? I mean, there is such a huge difference that the very few studies on the small intestinal microbiota show that there is a huge difference in composition, and there is a huge difference in function, and there is a huge difference between colonic and small intestinal the immune system and immune setup. The anatomy is different already.
Right.
So as you would expect, the small intestinal microbiota is much more sensitive to diet, because
Right.
the diet is much more varying up
Yep, it's
in the small
receiving
intestine.
way different
Yeah,
things. Yeah.
and what we do know is that the bad guys love to gorge on simple sugars. So then you have a kind of a overgrowth of these simple sugar digesters, and these happen to be high lipopolysaccharide producing gram negatives.
Right.
So you have high levels of lipopolysaccharides, and no wonder when you eat a donut and you provide
simple sugar and fat
simple
for
sugars and the
chylomicron.
fat then you have a high translocation of lipopolysaccharides.
And I guess we don't actually know necessarily, or something that I would want to look into is, if that donut contains, let's say, oxidized fats from being deep fried and reused vegetable oil, what impact does that oxidized fat have on the bacteria? Is it possible that that would cause an increase in bacterial die-off, which would then increase the amount of lipopolysaccharides even more? That would be a very interesting thing to find out.
That's mainly guesswork, I believe. At this point, I haven't found that there are very few studies, and all these small intestinal microbe studies point to one direction, that fecal studies are not really translatable to small intestinal stuff.
That would make a lot of sense. I guess the tricky part is, how the heck do you measure the small intestinal microbiome?
There is huge anatomical difference between mice and humans, because already the ratio between the two, the small intestinal surface, for example, I believe surface is much more important than volume in this case, because all these researchers try to emphasize their point, the research, what they are doing, that colonic flora is very important because of all the short chain fatty acids and so on. But it's not the volume what's really important, but the interaction happens on surfaces. And the human small intestinal surface, I think it's an order of magnitude higher than the large intestinal surface.
Right.
So when you are talking about surface, and bacteria are mainly at the surface, and in the colon they fill up a much larger space in the lumen. But what's really interesting is the surface. And the surface is much higher in humans compared. I mean, the relative small intestinal surface compared to the colonic surface is much higher. So we really should be looking at that, and barely anybody does so.
I mean, my guess is it's just a difficulty to measure, right? Because you can measure the colonic and fecal microbiota by just having, sticking a swab.
It's coming. I already saw these. What is it called? These
like a swallowable sensor.
Yeah. This not only the sensor, but what they send up to the now I don't even remember the name of these planetary stuff, which the Japanese
probe, a lander.
Yeah, probe just sampled.
Right.
So these sampling devices which you can swallow, and then actually it will sample all along the small intestines, and then you shit it out, and then you get all the samples from the small intestines. So
if you
it's
know of
coming.
such a device that exists, you'll have to let me know. Maybe I can get my own small
I
intestinal
saw
bacteria tested.
saw the news on this one very recently.
Interesting.
So
Nick and I were just talking about that yesterday. How the heck do you sample? We saw
there
your
are
tweet about the difference, and we were
there are a
curious,
few
like, how do we
studies
do
on.
this?
Yeah, there is one I remember on ileostomy patients.
Yep.
They had their large bowel removed, and then their terminal small intestine is just attached to their abdominal wall, and they use these sacs to remove the excretes. And yeah, these guys are a little bit unfortunate, but they can serve science a big favor, because you can measure a lot of things which is otherwise almost impossible. So what you have is either duodenal, so the very first part of the small intestine after the stomach, because then you can use this endoscope and reach the duodenum. So that's doable. It's not a pleasant practice.
No.
But the other end, it's almost impossible. You should go through all the large intestines from behind, and that's not really a nice experience.
No.
Reportedly, I've never had that, but
me neither. But I have had an endoscope done, but I was knocked out for it. So that probably really increases. You got to go through all kinds of ethical board approval. Taking somebody's poo is easy, but scoping them all, that's a whole nother story.
And all the way up to the small intestines it's not really doable. So it's
difficult.
It's very difficult. So we have some rodent stuff, and we have very few human, but actually the human data corroborates the findings in murine models. So that's nice.
That's good. Yeah.
So it's what we can say at this point, that the small intestinal flora is distinctly different, and it is much more reactive to dietary changes.
Mm-hmm.
And we have been erroneously focusing on, for example, small intestinal bacterial overgrowth, creating this arbitrary definition of the breath tests. And that's only one special. That's a special type of dysbiosis.
Right.
So there can be many infinite types of dysbiosis which don't come with a positive breath test.
Right.
Obviously. So we only measure for specific overgrowth patterns, and all the others, which I think the most important ones, remain undiscovered, which is crazy, because I think everything starts with at the interaction of food, microbes, and the intestinal immune system in your small intestines.
Yeah.
So
how do you think, based on, you've obviously done a lot of research on the gut-derived hormones that you were talking about earlier. So how do those relate to the microbiome and permeability and the immune system?
Yeah, I've been trying to find direct links between the imbalance in intestinal hormones and the inflammatory profile, but there is very little out there, to be honest. So I'm always excited to find that, for example, GIP is associated, high GIP is associated with an increased inflammatory response. And then 2 weeks later, they retract the article for some formalities, and then you are not able to use that reference as a great reference. But it was only some formalities leading some self-plagiarism. It was not the results which were questions. So that's really a pity. And there is the opposite one, how GLP-1 contributes to lower inflammation, for example, in adipose tissues. And then it was again retracted after a month or two. So it's crazy. You have really a handful, and then half of them are retracted. It's crazy. So I've been really waiting for some conclusive evidence, but I suspect that it is there. There is a connection, because
I guess we can
these.
definitely say insulin is related, because there's plenty of papers and evidence which shows that the
Yeah, but
inflammatory response leads to insulin resistance. But that's downstream, right?
that's already the chronic hyperinsulinemia. So when you have acute insulin responses, those are actually anti-inflammatory. So
Okay.
the kind of every meal creates an inflammatory response.
Yep.
There's a nice article from a Swiss group from Basel, I believe, and they found that interleukin 1 beta goes up after every meal, and it stimulates insulin in the beta cells. So it's another factor which can augment glucose stimulated insulin secretion, GCIS, and it is necessary to provide a higher insulin response, so that you have a higher anti-inflammatory response, so that all this food which comes in a wave, like the insulin curve, and it helps resolve this inflammation which the food creates. So acutely, insulin is anti-inflammatory. That's clear, and also GIP is anti-inflammatory, which these two usually act perfectly together. They have very similar actions on different cell types. Is the problem when you have chronic hyperinsulinemia? But the chicken and egg question is how chronic hyperinsulinemia is created, because that's not clear. A lot of people say that you eat carbs, you have high insulin, and then you have chronic hyperinsulinemia. That is a very important link missing between the two.
Yes,
because
exactly.
when having higher insulin peaks, or even areas under the curve, doesn't lead to chronic hyperinsulinemia.
Right.
So
I mean, by my approximation and research, it seems like chronic inflammation is probably the driver there, because TNF alpha and IL-6, for example, cause insulin resistance at the muscle, which then could lead to insulin resistance elsewhere, which is good. You want it for the immune response, because that's kind of, I guess, how the body diverts fuel into the circulation for the immune system to use, which seems like a good response in the case of infection or
that's why
tissue repair.
half of my open tabs on my iPad deal with the immunometabolism, which is a new science branch, which deal with this bi-directional relationship between systemic metabolism and the intracellular metabolism in immune cells. And it seems that these two have a very interesting relationship. Systemic metabolism can influence the type of polarization or type of immune activation, but at the same time, immune cells influence systemic metabolism, so that they alter fuel fluxes towards the desirable, so that it supports the actual immune response.
Right.
So that it's completely bi-directional, and it's a fascinating new area of science.
Yeah, that is really interesting. I think there was actually an article that was written for the lay public about the relationship between the immune system and things like that in the Atlantic recently, where they looked at taking antibiotics causing weight gain, which was pretty interesting.
And it's not nice to say, but we don't understand shit in this area. So I think we really need to dig into this a lot more deeply in order to better understand how these things works. Just I think 1 or 2 days ago, I posted a study on Twitter published in Cell Metabolism, which uncovered that even though T cells are characterized by this anaerobic glycolysis or glycolysis or whatever it's pronounced in English, but it's not driven by that. The inflammation itself is driven by impaired fat oxidation in the cells. It's a typical type 2 diabetes like activation of T helper 17 cells. It's a very nice article, and again it reinforces that we shouldn't stop at blood glucose when talking about diabetes.
Right.
Blood glucose is a very late symptom, and we should look upstream. And just one step above is this kind of lipotoxicity, this fat overflow, which directly causes hyperglycemia. And it seems that it causes the impairment also in mitochondrial fat oxidation. So
Yeah, I
immune
think
cells
the
are
low
just
carb community
screwed.
has kind of pushed towards looking at insulin instead of glucose, but I'm guessing that there's even more to it than that needs to be looked at. There's a pretty strong link between the immune system and insulin and
Yeah, I find that a lot of
high
people have a
inflammation.
relatively poor understanding of immunology, and just a few years ago I also did. So it's no wonder what I learned in the mid 90s or early 90s is completely outdated.
Right.
This field has been developing so fast. It's crazy.
Yeah, I
And
mean, there's so much to learn, and it's really
yeah,
complicated with all
I
these
had to
toll-like receptors and
almost completely relearn immunology from scratch, because it's so much different now than it was 30 years ago. It's
that's pretty
very
wild. Yeah, I
very
mean, it's
very
been very interesting to read all the immune system research and learn about the adaptive and innate and
yeah.
antigen
And when you
sampling
say
and all
when you
this kind of
say
stuff.
it's the inflammation stupid, then they say, ah, come on, inflammation is there to resolve the problem, and inflammation is too broad a term. So what's the problem with inflammation? Then you start explaining all this stuff that, yeah, there are different types of immune activations. There is the innate immune system and the adaptive immune system, and then you can have different types of polarization of cells, and it's a spectrum. It's not even you have an M1 type macrophage and an M2. No, you have a spectrum. One is closer to the M1, and another one is on a different place on the spectrum. So it's not as simple. But yeah, if you want to use one single term, single word to phrase what's the problem, it's the inflammation. And then of course you have to look for the root of the inflammation, where the inflammation is coming.
Right.
And what you usually find that all these diseases, cancer, diabetes, cardiovascular disease, all these are very closely related to visceral obesity. So then you start thinking about what visceral obesity is. I mean, why you would store a lot of fat within your abdomen instead of under your skin? Why does it make sense? And then you realize the role of different adipose tissues. Hey there. And
hey, sorry for joining a little late here.
it's not
No
late.
problem. Better late than never.
I have plenty of time, so we can start all over if you want.
No, I've been
I think we
listening
got
to
some good content. I think we're good.
Yeah.
So then you start considering, then you start realizing that adipose tissues have been a little bit misunderstood, and they are very, very different. Different depots represent different things. So when you have a look at your bone marrow adipose tissue, which is around 10% of your overall adipose tissue mass, it behaves very differently compared to any other adipose depots. Or
right.
when you're looking at the mesentery as a specific depot, it behaves very differently, even compared to the omentum, which hangs from your stomach, and not to mention your perivascular fat depots and your epicardial fat depot, and even your subcutaneous fat can be divided to superficial, deep, and they behave differently. So it's crazy.
Wow.
I mean,
there's
this
so
area
much to dig into here.
yeah. So it's and then you realize how certain adipose tissues, basically all of them, but some more than the others, work together with your immune system. That in a way that whenever you have immune activation, the surrounding fat cells are also activated, and they start providing the necessary lipids for the immune cells. And actually, they provide these lipids in a very selective way. It's not just they spur out all the lipids they contain in a random way, but they provide the omega-3s and omega-6s, which are necessary for the immune activation, producing
wow.
the prostaglandins and everything. And then
That's very interesting.
then they increase their mass around for example, the lymph nodes. If you have an activated lymph node, it's well established that the surrounding adipose tissue is activated and expands. So when you see an adipose expansion in some tissues more than in others, it can be considered as an immune activation. So if you have if you have adipose depots with normally very high immune activity, as the mesentery, which drains much of the small intestine and some of the large intestines, then is it an immune overactivation or overfiltration of something which is escaping the intestines, or is it just eating too much? So
I'm going to lean towards the immune activation.
Yeah.
I think.
What I think is really interesting about this space is that there's constantly this tension between a maker versus a marker. Like, is A causing B or is B causing A? Because that's like a personal fat threshold hypothesis would have told you that the reason that the inflammation happens is because we ate too much. But all of a sudden,
it's very interesting. I think I was one of the guys something like 3-4 years ago who very strongly championed the idea of the personal fat threshold. But I have moved along, and some people don't really like to see me moving along, and I find myself in different camps all the time, because some remain and I move, and then I change my mind, in a little bit at least, and I tell that it might not be the initiating step in this pathway, and what we see could be considered this way. And then they say, but we had a beautiful solution. You eat too much, your subcutaneous fat overflows, and then it's deposited in your visceral fat depots, and then your visceral fat depot overflows, then it's deposited in your liver, and things are explained perfectly. So then you start looking into all the studies in rodents, and in rodents it definitely works otherwise. So it's not how it works in rodents. And then you question, okay, let us see whether it works the same way in humans as in rodents, or not. There are so many important differences between the two. I mentioned the length of the small intestines, the ratio between the small intestinal surface to the large intestinal surface. So I'm not sure everything is 100% translatable, of course, but there are some very nice similarities which we can use, at least as a starting point for another hypothesis.
Apologies if I missed this, but I've heard a lot about the incretin response, and now we talk a lot about immune response, and they almost seem like they're independent. Is there an overlap between the two?
Yeah, I've been trying to find some kind of supporting evidence, or any evidence for that matter, because information is scarce. There are only two groups, or two guys who are deeply into this. I think I will be able to provide references after that, but it's mainly about GLP-1 and how the L cells are also sensors for the immune system, and provide information to the surrounding immune cells about, provide clues about what's happening within the lumen. And there is almost nothing about GIP, but we have indirect information that suggests that GIP and very high, very frequent GIP curves kind of inflammatory in adipose tissues. And what happens in visceral adipose depots, for example, in the mesentery, which is very, very close and probably sees much higher concentrations of these hormones, we just don't know. So there is no information, basically. It's very, very compelling, or even tempting, to say that this imbalance, what you see when you disrupt plant structure, carbohydrate-rich plant structure, there is a direct connection to inflammatory responses, but the information is simply not there. So I would love to say, because this is kind of a pet theory for me, that what I discovered for the hormones, it's fully translatable to the inflammation part, but unfortunately the information is very scarce.
And I guess to throw together an ad hoc hypothesis, which I know Nick doesn't like, but you could say that, let's say that eating these acellular carbohydrates causes an imbalanced incretin response, which then stimulates hunger sooner. Means that you're eating more frequently, which means that you're getting more opportunities to have immune activation and inflammation and have bad things happen, and you're providing more fuel to the bad microbiome and all of that. So that could be a weak link.
I think the link to hunger is definitely there, and since I gave this presentation in Prague May last year, there have been a few nice studies that uncovered further molecular mechanisms. For example, there is a mice study which clearly showed how the increasing ghrelin, the hunger hormone, coincides with the dropping glucose, and you need both in parallel, so that these agouti-like neurons in your hypothalamus perceive it as a kind of danger signal, and it creates the hunger feeling. So it's not enough that you have the ghrelin, you need a concomitant drop in glucose. And this is exactly what you see when you eat these ultra-processed carbohydrate-rich foods, that you have this hyperinsulinemic response, this disproportionately high insulin, and this disproportionately high insulin just pushes down your glucose below baseline, and it's very fast dropping of glucose coincides with a very quick surge in ghrelin. And that's a clear hunger signal. So that can nicely explain what the community usually calls the carb craving, or this 90 to 150 minute hunger feeling after even a large meal. But
right, the Chinese buffet effect.
Yeah. When this large meal creates this hyperinsulinemic and hypoglycemic effect, then you clearly see this one. And actually, it was shown without some of the hormones even discovered then back in 1977. And it was published in the Lancet, the famous or infamous apple processing study, when they measured blood glucose, insulin, and subjective hunger. And back in the 70s, these guys were really healthy, lean and healthy. So it was before the obesity epidemic.
Right.
It was relatively easy to find healthy controls, and everybody had a fasting glucose of 70 something. And then they saw this quick surge of in insulin after drinking the apple juice, for example, compared to eating the whole apples. And then I think their blood glucose went down to something like 3, which we multiply by 18. What's that? Yeah. So it went down
50,
to
54.
Yeah, that can be considered hypoglycemia, or not even mild, but severe hypoglycemia in average people. And then in those cases, they noted the increased subjective hunger. So this was demonstrated how many? 40? More than 40 years ago.
Long time ago.
Do you guys think, so one of the things that I'm concerned about is when you look at one of these studies where they're talking about endotoxin absorption, is that they're using healthy controls, which in modern, just yesterday, BodySpec sent me their percentile curves for visceral adipose tissue in Americans. And what's crazy is, at this point, I fit into like below the 20th percentile mark at the 20 to 30, which is the lowest range they have. And that basically just kind of monotonically increases, such that, in a 20-year-old, you've got your 20th percentile would be something like 0.18 or 0.2 pounds of VAT. By the time you get to, I think, 50s or 60s, the 20th percentile is up at a full pound of visceral adipose tissue. And it just kind of, I'd be interested to use VAT as a proxy of metabolic health, if that seems reasonable, to see like what percentage of people, because it looks like the number of people that would fall into some threshold are almost vanishingly small in the US at this point in time.
I think it was a Chinese study, so I don't know how much it's to what extent it's applicable to a general population, but they found the with ultrasound mesenteric fat thickness of 10 millimeters, which is less than half an inch, as the threshold, and above these 10 millimeters, every single millimeter additional thickness represented a 37% increase of metabolic disease.
Wow.
A millimeter is 1/10 of a centimeter. A centimeter
Yeah.
is less than half of an inch. So every millimeter adds a 37% extra
Should we buy an ultrasound?
risk. So if you have an extra centimeter, you have an extra half of inch. That's 12.5 times 37%.
That is wild.
That's half an inch
huge,
of an extra
amount of
mesenteric fat. That's not a big deal.
Yeah. I might
If
have
you
to buy an
consider a
ultrasound.
waistline half an inch thicker, that's almost nothing, and
Yeah, you can't even notice
that's
that.
already 400 something percent extra risk.
Wow.
It's pretty crazy.
So you talked about acellular carbohydrates as a problem, and we've seen.
Yeah, I don't like the word acellular. I like the phrase quick absorbing, because it's all about the speed of absorption.
Okay. So do you think, or looking at those which have increased in the food chain, we also have all kinds of food additives and potentially more fructose, maybe emulsifiers or liquid fats. Do you think any of those are particularly responsible for the increase in chronic disease that we've seen, and how it relates to permeability and incretin secretion and all of that?
I don't know about any, but I would say many of those are responsible for metabolic problems in general. Emulsifiers, yes, definitely. It's I think the evidence is rather straightforward regarding that. We have a lot of chemicals in our food chain, and not only in the food chain, but in our homes, like different plastic derivatives and BPAs. The new BPAs seem at least as bad as BPA A or whatever was
it's
the
not
old one.
bisphenol A anymore.
Or BPA S or B or whatever. It doesn't matter. It's at least as bad. So we have all these endocrine disruptors, and they seem to converge upon the very same pathways of hyperinsulinemia and insulin resistance, and increased gut permeability and enhanced immune activation. So, and then we have our other factors in our lifestyles other than food. Sleep is very anything stress related, basically, because inadequate sleep or bad quality sleep creates a stress response, and the psychological stress, other kind of chronic stress factors in our lifestyles. Again, Cushing's syndrome, where you have
increased
very high
glucocorticoid
secretion, and it's associated with a huge abdominal fat deposition. So if you have systemic high cortisol, that creates selective deposition of fat in visceral depots.
Do you think that's causal to, or is that causally related to increased intestinal permeability? I know that stress increases intestinal permeability, or that's been shown in some studies, but
I think it's
does cortisol directly impact?
I think chronically high cortisol, yes.
So I guess that ties almost all of it back. I mean, that's pretty fascinating that
if you check all these factors, smoking is a very high risk factor for cardiovascular disease. Smoking is associated with a disruption of gut barrier function. If you have mice smoke, they develop all these visceral adiposity. Smoking cessation comes with a huge improvement in dysbiosis in mice. So I think all these channel into the same old mechanisms. And what you see is that it's no wonder, because there is a very close connection between the lungs and the gut. There is a gut-lung axis. Now it's recognized. So
Wow.
the lung mucosa has only local lymph support, and then it seems that some of the visceral fat takes over the load from the lungs. So
Wow.
these stuff escapes all these toxins, and then it gets deposited in the visceral fat, creates the inflammation. Inflammation creates the increased permeability, and then you are there. So there is almost nothing for which you cannot find a connection to gut issues.
Is there a reason that
interesting.
Is there a reason that the permeability is driven by inflammation? Is it just a damage, or is there potentially a reason for that was beneficial?
It seems, I think I have at least I think 3 different papers showing different barriers opening up in response to inflammatory processes. One we have already discussed was when adipose tissue expands, and it needs to quickly expand. It can be a reverse causality, because at least in mice it was shown that for healthy adipose tissue expansion, the necessary inflammation is produced by the body by opening up the gut barrier. Because otherwise the body cannot create the necessary inflammation, cannot create the activation of, for example, the macrophages, which requires the TLR4 type of activation, and there are no internal ligands, at least not in enough numbers. So it requires some kind of inflammation, and where we can get the inflammation, we have these little bodies living in our guts, and then just let them in. And
that would be kind of an interesting way to explain the personal fat threshold. If you had a very impermeable intestine, your body couldn't expand your fat cells appropriately, or if you didn't have as reactive immune system or something like that, then you wouldn't be able to expand your adipose tissue, and then you would have excess fuel floating around, insulin resistance, all of that kind of stuff from the lipotoxicity, which would be kind of interesting.
We also discussed the different route normally long chain fatty acids take, so that they are not absorbed into the blood circulation, but instead they are absorbed into the lymphatics, so that they can go first to the mesenteric lymph nodes, so that they can filter chylomicrons for LPS, for example, before entering the circulation. And what leaky gut is, in fact, if you have higher LPS load on your mesenteric immune system, can that be considered leaky gut? Doesn't necessarily. So I think if you have this intercellular openings between the junctions, then your lipopolysaccharide takes a different route. It goes directly to the portal circulation and reaches the liver first. And if the liver is overwhelmed, then it reaches other tissues. It's very difficult to see how all this happens, and what could potentially explain the differences between what we see in different people. So yeah, you see the extremely huge, those almost 1,000 pounds, they never get diabetic.
Right.
They seem to be able to expand their subcutaneous fat indefinitely. So that's crazy. Other people, it's most likely a huge part is genetics, but what in genetics? That's a huge question mark.
Seems like there's not a huge amount of research on the genetics of the immune system. Like I was trying to look, I've done a whole genome sequence, and I was like, I wonder if I have any toll-like receptor variants or any my D88 variants or MD2 variants, and like there's very few identified or researched variants. There's
Yeah,
a couple for toll-like receptors, and those have interesting impacts on statins efficacy and things like that. But the MyD88 couldn't find a single thing.
Yeah, and the problem is, I believe that some is determined by genetics, but much more is determined by epigenetics,
Right.
and then in intrauteral conditioning, and then how you are being exposed to microbes during and after birth.
Right.
Those are critical.
Yeah, I'm guessing that the hygiene hypothesis does probably play some kind of role here.
critical times for proper immune activation and immune maturation. And if you miss that few first months or the first year, it's very difficult to create the same kind of activation for your immune system later. That's why all the allergies and autoimmune diseases spread like crazy, because people just have under conditioned immune systems, and when they actually finally meet with something, they overreact.
Right.
So
yeah,
it's a delicate balance between activation and tolerance. Your immune system needs to find the right balance. Obviously, the intestinal immune system is kind of unique from this perspective, because it's always in connection with a lot of external stuff, and it has to be tolerant, because if it's not tolerant, it's a continuous high level of inflammation, which is counterproductive. So for example, I still don't fully understand if the problem is over tolerance or over activation. It sounds weird. I believe that we cannot really tell, but based on the hyperinsulinemia as a marker, and as we discussed earlier, acute insulin responses are part of the anti-inflammatory response to each and every meal. And when you have chronic hyperinsulinemia, could it be considered as a chronic non-resolving inflammation? So you have this resolving phase stuck and going on, trying to resolve, but you cannot, because you have the stimulation coming at the same time continuously. So hyperinsulinemia could be thought of as a resolution phase, chronically stuck, for example.
Attempting to mask the effects of or reduce the inflammation.
Yeah.
Yeah.
Well, so these are things at least I don't really understand. So I've been delving into this immunometabolism thing for a year or so now, but it's a very deep rabbit hole.
Yeah.
Oh yeah.
One of the things that I really want to explain is this observation by Nina Teicholz when they went back in the medical records and they were trying to find evidence of angina or heart disease prior to 1900 or so. And the conclusion was that there was not, relative to other diseases, even chronic diseases like gout that would have triggered a lot of pain and actually showed up in the medical records with frequency, that it was very rare to get a diagnosis of angina or, I mean, much less a heart attack prior to 1915. And that was very interesting to me because, I mean, a lot of the popular writings on the subject say, oh, heart disease was always a thing and it always will be a thing, but it's just because of life expectancy that we all died at 37 years of age in the 1800s. That's why we don't see it. But it's a very interesting observation to try to explain from this perspective, because from what I understand, there were some similarities in the 1800s with our diet. Like, they appear to have had some amount of bread in their diet. The exact level is definitely not clear. You know, it wasn't like there wasn't stress in the 1800s. You know, they fought wars in the 1800s. And so I kind of understanding the differences in the environment and the nutrition and all of these things that could help pin down, because there are many different possibilities, and it's unfortunate that I haven't found better data looking into, you know, what were the differences in nitrogen isotope ratios between someone in the 1800s in the United States, for example, versus by the time they started seeing these problems in earnest in like the 1930s and 40s.
Oh, that's interesting. That's something that should be able to be studied. Have you looked for that?
I have, and no one
Oh.
has yet been able to point me, because stable isotope analysis, I think, would be because kind of
we would know how much protein they were eating.
the root thesis of the vegan ideology is that we used to eat nothing but grains. Basically, that the grain consumption in the U.S. in 1880 was double what it was in 1970, and that fell off a cliff, and that the absence of the great grains in the diet is the reason for all of our maladies. Ignoring evidence that, like, Lewis and Clark ate 8 pounds of meat a day, and that in theory they should have been having diabetes if 8 pounds of meat a day is sufficient to cause. But that's the kind of thing that I want to do to kind of tie this line of inquiry into the heart diseases, to understand those differences, if that makes sense.
Yeah, I understand that most people like to see simple ideas, or at least pinpointing one factor that does the major contribution to this health problem of our age. But I believe in most cases, yes, diet is the biggest one, but we have all these others I mentioned, the sleep, the chronic stress, the BPAs, and many others, which may converge upon the same pathways. And then there is obviously that there has to be a kind of a threshold. What when it is reached, then it wreaks havoc on your system. You have some capacity to correct, and then it also comes to the autophagy, the chronic suppression of autophagy, for example. Continuous eating from early morning to late evening, 24/7, and then every day, every week, every month, and every year. So there is no stop to this in lives of most people. And I have a thread on Twitter running on this chronic suppression of autophagy, and it's linked to so many problems we see developing.
Yeah,
so
I found some interesting papers.
The system is capable of getting rid of the problems if you leave enough time.
Right.
But if there is no time, there is no getting ridding, or whatever it's however you say that.
Makes sense. Yeah, I came across some papers that was showing like reverse cholesterol transport is modulated by autophagy, and seems like that's a pretty important process that both.
Yeah, in cardiovascular disease, the immune stuff cannot be ignored. I think all this debate coming and going on different social media, that LDL is important or not important marker or whatever. I mean, when you can clearly explain one alteration with an upstream event, any focus on this downstream association should be well, not ignored, but just okay, it's there, and let's move on. So when you see on the balance, you see both ends changing in the wrong direction when you have an inflammatory response, even an acute inflammation or an infection, and you see that serum amyloid A substitutes ApoA1 in HDL, and your LDL changes to a much more heterogenic profile in 1 or 2 days. And then when it's resolved, it goes back to normal. And so why don't we just think of the problem as a chronic inflammatory phase? And then you look into, okay, what type of inflammation, and why in some cases we have increased LDL-C, for example, while in most cases when you have an infection, LDL-C drops. And in many cases, when you have cardiovascular disease, high risk, LDL-C increases. And what's the difference? Is there a type of inflammation which can increase your LDL-C? Is there an exception? And when you look for it, you find that there is. There is one specific inflammation which causes elevated LDL-C, and it's called small intestinal inflammation.
Well,
very interesting.
Very interesting. That
when you know what to look for, it's much easier.
So,
oh yeah.
If I wanted, I mean, one of the other places that I think is fuzzy at this point is if you were talking about the link between the inflammatory response and the circulating endotoxins and the initial stages of atherogenesis, because the pathology of early stage atherogenesis begins with kind of the abnormal dedifferentiation and proliferation of vascular smooth muscle cells that are kind of rather deep within the wall of the artery. They're kind of like in the media, and they begin to grow into the intima. And that we talk a lot about the endothelial interactions, because if you have circulating endotoxins with low and slow flow, that expresses TLR4 and could kickstart the immune system. But in theory, you know, there are many different pathways that could get you from that to these beginning stages. And I'm just not sure if you have any insight on that region.
The primary question we should ask first is whether this is really important or not. In this case, I actually prefer the view of the balance theory. So what is used in obesity, that you are consuming more calories than what you expand, and then that's the root cause of obesity, which is of course a ridiculous idea for a biological system, that it's thermodynamics which causes the problem. So, but in this case, when you see something building up, you can actually use, at least for a thought experiment, you use the same logic, that you can have increased delivery of the bad stuff and or reduced removal of the bad stuff. And what you find is that in this case, actually, it pretty much works like that. You have this oxidized LDLs and the really bad stuff increasing with inflammatory responses. And in small dense LDL, the oxidized lipids are much higher, and lipoprotein A, it's a prime carrier of oxidized lipids, so that's why it's so atherogenic. And when you check the other side of the equation, the removal of cholesterol, for example, reverse cholesterol transport, you recognize that as soon as the inflammatory response exchanges your ApoA1 for SAA, serum amyloid A, it loses function. It not only loses function, it becomes pro-inflammatory. So it is there to support the inflammatory, the immune activation. And then you have the imbalance between the two on both sides, increased delivery and reduced removal. So the funny thing is that in this case, it might very well be a very valid model, contrary to the obesity model, where it's just funny. I prefer to use the analogy which is met by huge I don't know, I get crazy responses when I say that is fever caused by an increase in heat production and the reduction in heat dissipation? That's a thermodynamic model of fever. There is no way that your body temperature could go up without either increasing heat production or reducing heat dissipation. It must work like that, because it's basic logic. It comes from the first law of thermodynamics.
Exactly. And why they say that rich?
They say that I'm talking about something completely different. This is the typical response I get. You are talking about something completely different. You don't understand this.
You've broken the perfect hypothesis.
I'm having the same analogy. It's about energy. It's about energy conservation. Your body temperature can only increase if you produce more heat and or remove less. That's basic logic, and it has to follow the logic of the first law. And then they look at me that this guy is crazy. But I come on, you are crazy because you are telling me that this is the root cause of obesity. It's not a biological approach. I understand thermodynamics, at least to that level. I'm not a physicist, of course, but I understand that the underlying energetics must follow, and it does.
The thermodynamic approach is pretty readily, at least discounted by anecdotes and probably by certain feeding studies. But I love seeing these old zero carb forums where people are like, I'm going to eat 5,000 calories a day of mostly fat for 30 days. And the guy gained no weight. And you said you've done the same thing. I've done it recently. I think we're going to try and put together, an N of many overfeeding experiment where we'll get people on a, zero carb diet to eat 4,000 or 5,000 calories a day and get them to weigh themselves every day, and we'll see what happens. And my hypothesis is nobody's going to gain weight.
One of the experiments I've always wanted to do was to, if you had people who were overweight and you wanted them to lose weight, but instead of, you randomized them all to a meat-only diet where it was just basically steak of some quality. And then what you did is you randomized them between like a low calorie, a target calorie, and a high calorie amount of meat. I would be absolutely fascinated to see what the weight loss looked like in each of those different groups, because I don't think, I'm suspicious that it would not follow a caloric balance hypothesis of when weight loss happened.
You have to, when you are enforcing highly oxidative metabolism, you have to combine it with a toxin, at least with some compounds which are considered as toxins in high amounts. I guess the corn oil overfeeding study from the 70s. So those guys on low carb drinking corn oil all day long I think they didn't gain up to 5,000-6,000 calories a day, and most of them kept losing up to 4,000 like crazy, because the body wanted to burn off all this dangerous linoleic acid like crazy.
Wow. Huh.
And you just need to find the corresponding physiological pathways, how bile acids stimulate uncoupling through whatever lipid metabolites, and these kind of things are
there's some
amazing.
Super interesting stuff around that we haven't really looked into, or that science hasn't seemed to look into too much, which is the fibroblast growth factors, FGFs. And there's like a whole bunch of those, and some of those are stimulated by
big bunch of them.
Yeah, some of them are stimulated by by cholesterol, by fat soluble vitamins, which leads to do fat soluble vitamins and cholesterol increase satiety independent of caloric content? It seems like probably, since that has I think FGF19 has increases. It has a similar response to insulin, but without lipogenesis.
Yep.
Which is like, oh, well, that's kind of interesting. And those are not well studied at all.
Yeah, you have a lot of stuff on that, but it's really inconclusive. I believe it's you can spend days reading, and there is no TLDR at the end. So just okay, I read 10 studies, but what the hell? Yeah, we still don't know a lot of things about how the body works, and that's why when people stop reading and just are stuck at a certain level or certain point, a certain level of understanding, and they are happy with that because it proves their point or follows their beliefs. You see that it's so common.
Yeah.
It's confirmation bias that this study fits perfectly, so I add it to the 2 dozens of my library, and I'm a happy man. And,
so I guess following on from that, just kind of generally, how do you identify research that is, of interest and of high quality?
Yeah, I have different feeds coming. I have one list, Twitter list of journals, and then I have newsletters, the old way of emails, and then I have a pop crawler preset searches, 4 or 5 pre-set up searches coming every other day, and I have almost 8K of studies in my own library now, and reading stuff and finding references, finding citing literature of papers what I'm reading, and I still use some of the old RSS feeds.
Nice. So when you
Sometimes
find a paper that comes in via one of those methods, what do you use to evaluate it? What do you have, like a mental checklist of how to identify if the paper is kind of worth including into your mental model?
yeah, it's difficult to tell. After a few papers, you develop this kind of sixth sense of kind of an instinct that if you start reading the abstract, the language, yeah, you know, maybe it's biased, but you check the journal, what kind of journal it is. Is it something at least relevant or reliable? It's not a predatory journal or whatever.
Right.
And yeah, many things. And then you do the quick. If you find it interesting based on the abstract, then you do a kind of a skimming. I developed this quick reading. I just read a little bit into the introduction. One of my favorite parts is the introduction, because then you get the type of insight what the researchers have, how deeply they are into this,
Right.
or what their understanding is in this area. If
Yeah, I
they
guess
give
if you
up,
read that and their
yeah,
background is
if
not
they
good,
provide a
then
very short background or introduction, and that's that they want to further emphasize their results, all the sometimes meaningless results. But if there is a very nice introduction, just the right one, the length and the depth and everything is there, and often you find the best references in the introduction part. So if it's a good paper, the introduction is one of the best parts. If it's a poor paper, the introduction is usually one of the worst parts.
I had thought about at one point just like showing people what I consider to be like a very good paper on heart disease versus like some of the stuff that somehow qualifies as a quality paper in the journal Atherosclerosis, you know, like what they look like. And one of the things for me was this idea that like they should be able to tell you the things that we don't know and what they're like, where you would look, you know, we don't understand this and here's what you might do to look into that, or here's another paper that provides background on that. Or
Yeah.
when someone says they know everything, that's for me that, I don't know, it's one of the things I kind of disqualify a paper immediately.
Yeah, sometimes you feel that it's an educating piece instead of a research publication. So
Yeah.
that they want to convey a certain message, or there is some kind of a push behind. Yeah, it sometimes leaks through the text.
Yep.
That
We've
it's
found that
some agenda behind, or yeah, I just somebody asked me today if there is a publication. It was accepted after review, and this is the first publication my name is on actually as an author. It was it's just an observational research done in my Facebook group, and then I also contributed a very little. I added some useful comments and references to the text, and then I was included as an author. Like I'm a participant in the lower insulin Facebook group in the USA. Okay, so that's the official contribution from my side in the paper. But the first author replied when I congratulated on the acceptance that it's not the New England Journal of Medicine, but still it's a good first step with this kind of ketogenic observational stuff. And then I said that, yeah, I find this paper interesting, but I get the weekly newsletter from the New England Journal of Medicine, and most weeks I find nothing interesting to read. It should be renamed the New England Journal of what was that? I added symptom treatment or whatever, because it's association between what and another thing, association between a third thing, and this drug and that drug, and this never proven stenting process, and whatever, these kind of interesting things. I just reading. Okay, no, nothing interesting.
The New England Journal
of
the New England Journal of Band-Aid Medicine or something.
Yeah, something like that. So high quality association between unimportant metrics.
Yeah, and reading the papers, I think your point about the intros is very interesting, because when you read a paper and it's claiming to be, or it's presented as, let's say, you know, this paper really shows the pathophysiology of atherosclerosis, and in the intro there's statements like, you know, the LDL is in the, you know, enters the artery wall, or, you know, with no mechanistic statement whatsoever. It's just like this thing happens.
Yeah, but it seems that the LDL can indeed enter the arterial wall by active transcytosis or
Oh
whatever
yeah,
it's called.
I don't doubt that, but
I would expect them
if
to
it's
put the word
transcytosis, they should put the word transcytosis in there, or they
I
should,
think
explain the mechanism by which these things happen instead
I
of
get the sense that a lot of
stating
people in that
here.
field don't want to put the word transcytosis, because as soon as you articulate that it's an active mechanism, all of a sudden a whole host of questions come up about the characteristics of that active mechanism, and then therefore is concentration relevant to an active mechanism with feedback control. And they seem to just absolutely avoid saying that word,
Yeah,
accepting
but
that.
then the question arises almost automatically why there is an active mechanism to take up LDL into the
Exactly.
arterial wall, and then you start thinking about the different roles of what lipoproteins play, and then there is an anti-inflammatory, then there is the other immune roles of lipoproteins, and
they've thought of that one. There's a paper that LDL drives atherosclerosis by active transcytosis driven by SRB1 and the DOC receptor to cause atherosclerosis. Like the statement of the paper is like, this mechanism exists to cause atherosclerosis.
Oh yeah, that's a nice mechanism, and it was specifically developed by humans because other animals don't seem to develop atherosclerosis whatsoever. So it's a specific trait of humans that we evolved the transcytosis system to develop. Yeah, it's a good idea.
It's funny.
I did have one other mechanistic question about the mesenteric fat. So that's where the chylomicrons end up going through to be filtered, essentially. So are the contents of the chylomicrons essentially dumped into an adipocyte and then reabsorbed once they're filtered or something? Do we know what the mechanism is there of how kind of the mesenteric fat acts to kind of filter the dietary input?
I'm not aware of such a mechanism at the moment. I'm into some mechanistics of chylomicron secretion itself, because it seems that there are huge differences between how much lipopolysaccharide is taken up in chylomicrons, depending on a lot of stuff, and our understanding is still pretty much lacking in that respect. So I'm trying to find out if this is again a very active process where you kind of sample the lumen content, but I'm not there yet, so I don't really know.
Yeah, because that gets kind of interesting, like looking at why a high-fat diet would work if you're actually increasing the amount of chylomicrons you're producing,
if you have
increasing how much is going through. It's kind of
if you
interesting.
have low LPS producers, then I think this sampling provides normal levels of LPS,
Gotcha.
for which your system is totally prepared. And you take it up, you can handle it, you get a clue what type of LPS is there, what type of microbes are there, and it's just cleared up, and there is no problem. The problem arises when you have enhanced. It starts with the dysbiosis. You have high LPS producers, a lot of debris. You have the high fat coming in, and you have the enhanced chylomicron secretion. So you have a triple whammy, and then it overloads the system. That's my best guess right now.
Makes sense.
The threshold.
Sorry, go for it, Nick.
Yeah, I'm attracted to the threshold model from just a high level, because I mean, you can have multiple things that are affecting this threshold. It's inappropriate immune conditioning could be possible. You can have multiple different inputs, but it gives you like a common mechanism that you can look into and dig into and understand how these factors are pushing, because it's clear that there's interesting characteristics about these chronic diseases in terms of some of them seem to show up earlier. Like we appear to have had some amount of arthritis and gout prior to heart disease becoming prevalent, and I'd like to be able to explain all those observations when we have a model like that, if that makes sense.
Yeah, I think I strongly suspect right now that we need to dig into differences in immune systems or immune activations between different people in order to understand why similar etiologies lead to different outcomes, kind of. So if you have a very similar starting problems, why some people develop these autoimmune diseases and others go to the quicker diabetes development, or the switches between obesity and diabetes and cardiovascular disease. So these, I think, can be differences in the initiating events, maybe the chylomicron transport of LPS and the transcellular uptake of bacterial debris, so the true leaky gut, they convey different messages, and God knows how many differences there can be in the initiating steps. And then these differences from the beginning face the differences in the individual immune systems, because those are highly individual. What you inherited, what you developed as a small child, and then how it was altered later, and epigenetics from 2 generations up, and many things influence your immune responses. You probably are aware of the hypothesis. It was recently published in, I don't know, PNAS, the National Academy's journal, by a lady. I don't remember her name, but she posits that visceral and subcutaneous obesity should be viewed through the glasses of costs of immune systems, investing into immune systems or investing into storage systems. So if you have a kind of a skewed you are skewed towards heavier immune investments, which made more sense throughout most of our evolution, that you have a stronger immune system, then you are more prone to developing visceral obesity, because that's the immune associated type of fat. And so this is very compelling type of thinking, but yeah, let's find the evidence.
It just seems like this system. I don't know the state of the art in understanding epigenetic factors. Like, are we able to dig into that? Is that something that is accessible to us and comprehensible to us when we're trying to understand the activation of these systems? Or
yeah, there is a big thing in epigenetics. I abandoned this a couple of years ago. I can dig up the studies I have, but it seems that it really goes through 2 generations. So if your grandpa had a problem of starvation or abundance or whatever, you get this program with his sperm. So it comes around, and the other thing is the mitochondria coming from the mother. But yeah, it was very recently found that there can be some mitochondria passed on from the fathers. So it's the system is getting more and more complex as we are digging.
Yeah.
Unfortunately, so it's less and less easy to cut through it and find simplistic solutions.
Yeah.
Yeah, but it'll be interesting if we can at least understand this system in terms of what it's doing and make those comparisons between people. Even if we can't delve into those details, we could get some insight into what these differences are and why people react so differently to
I started working with a group, and hopefully soon I receive a device to be able to measure my own insulin, CRP, C-peptide, and these kind of molecules at home. Wow. In the long-term plans, there are some other molecules which is still a little bit plastic, or it can be changed. It's before final decisions. What kind of molecules should be measured at home in the next wave? For example, should it be lipopolysaccharide binding protein, or which interleukins? There are some nice ones, 22 and 1 beta and whatever type of interleukins, and what is possible technically on these strips at all. And yeah, it's really exciting, but sooner or later you need to get the science right to be able to tell which to measure.
We We're very interested in looking into that, particularly with the capacity to do experiments on carnivorous controls, so people who are not exposed to, or people who take a lot of steps to be healthier or have avoided these stimuli for a period of time. And we're looking into like exactly, I guess those sorts of hooks, are there interleukins, or like which particular LPS assay or things would be most interesting to measure to try and characterize that difference in between health and what that looks like in a postprandial sense, or stuff like that.
Yeah, we have a setup. We can run ELISA assays in my apartment now, in theory. We haven't done one yet. We bought an insulin one, and we're looking into either the cytokine ones or LPS ones, or
must be similar to the one these guys are about to sell. They have had a device on the market, which basically a reader.
We've got basically the full chemistry lab one. We have like a microplate reader and a microplate shaker, and we can run like 96 well microplates.
Now this can be done from peripheral blood, and with the same. It's very similar to glucose, but just it's a kind of immunoassay. It's different. So and the cost will be more moderate, I think. Basically, you will need a phone app and a phone camera to read the strip, and then the analysis will be done in the cloud, and then it comes with a full visualization of you get the AUCs and everything.
Have you been talking with Eric?
Cool.
Yep.
Yeah, I've been interested in it. Yeah, we connected at Breckenridge back in 2018, so it'd be interesting.
They kind of pulled me in on that project, so I
didn't realize they have they have multiple different assays going at this point.
I think what they can do right now is insulin, C-peptide, CRP, and then they include a regular glucoketometer, which can also add total cholesterol and lactic acid, I believe.
Yeah, we were interested in. I don't know. I work at Google, so they keep pinging me to try and reach out to people in Verily. They're the ones that aren't still trying to like characterize Lp(a) or whatever is things like that. So we'll see.
Interesting. Yeah, Google Verily is doing a lot of computational immunologics, as is Microsoft Research, which is kind of interesting.
It would be cool to try and get in there and steer them a little bit towards this stuff rather than whatever other lipoprotein things they'll be doing for the next several decades. But
yeah, these guys, Eric and company, I don't think that they want to do any lipoproteins. That's not in the close plans as far as I understand. So those will be more metabolism related, peptide hormones and or LBP and these kind of things, and then maybe interleukins, some of them, which we
that'd be
find
interesting.
Yeah, so it's not official yet, and I don't know my status with them so far, but we have been discussing a lot of things, and I even give some sales kind of related advices. I used to have some sales experience, so we are trying to find. It's a very interesting model because it's part philanthropy, it's part trying to find funding from insurers and these kind of things, and then doing some pre-funding from enthusiastic customers who want to measure their insulin, C-peptide, and whatever's. So it's a big mix of everything, and it's not easy to find the right kind of business model because there is still no classic type of businesses. There are no plans to have a classic type of business out of that, as far as I understand. So, it's cutting through slowly.
Interesting. Any other questions, Nick, or should we wrap it up?
I think, I don't know. I mean, a million questions.
Shoot them, some of them at least.
Do you have any interest, Gabor, potentially in doing some kind of like regular chat to go over like the latest papers that you've gone, like a research paper reading group kind of thing or something?
Yeah, it depends how much time it takes. I still try to spare my time for actual readings, whatever I can.
Fair enough.
Because, yeah, we discussed I have 490 something tabs open on my iPad all the time, and I fail to clear up 100 or two, so that I always run into this 500 limit.
There's a 500 tab limit?
Perhaps
Apparently so.
I have an Air 2, which is from 2014 or whatever, so it's an old device. It's still okay. But,
you got to buy a new one to get the 700 tab limit. They'll charge you an extra $100.
Yeah, 1,000 tab limit. But I think first of all, I'd need this export function so that I could export all the tab names and links at least.
Oh, that'd be
and
good.
then I can save and reopen if I wanted to. But this was not a high on the agenda of Apple, probably. to create this. Nobody has 500 tabs open all the time, but that's too bad for all the papers.
Yeah. Oh well.
99% it's papers which are open. So yeah, but it sounds interesting to discuss some of the findings.
Yeah, maybe we can put like an hour on the calendar in like a month, and you can send us some papers. We'll read them, and then we could chat about them in the future, and we'll see if we want to keep doing it or not.
You can pick some from my Twitter feed.
Sure.
These days, I think I share most of the papers on the Twitter feed. I even spare the time of writing up a post for some of my thematic pages on Facebook. It used to be that my Facebook was linked to Twitter, so I shared on the page. Then I could share the page to the groups, and then but it's I already find it too cumbersome. I can spare a minute. I can spare 2 minutes a day, and then it's a full paper a week, full paper more a week.
Yeah.
So it's a never-ending story, I see. But
oh yeah. Well, it's awesome that you're always evolving your hypothesis, and we very much enjoy following along on Twitter. And
yeah,
awesome
maybe I should have a blog. I don't know. It's always the time I want to spare not writing up all this stuff, because it takes a lot of time. If your native language is not English, it takes even more time to write up a blog post, and then what I'm always afraid of, that 2 months later my opinion changes, and I should go back and edit all the posts from many years. That okay, guys, I found out that it is actually not really true. So
just have a little piece of software that marks all the papers more than a year or two old as like, I may not believe this anymore, just so you know. Like
I can basically mark all the papers that I don't want to believe everything, but it doesn't really depend on the age. Yeah, as we discussed, the Apple processing study is still a great one.
Yep.
From
it seems like a lot of the really good foundational research was done in the 60s and 70s, where
you can find really great things from the 60s and 70s, but at the same time, the tools have developed so much over these decades that what is possible now to look at is incredible.
Yeah.
So
seems like a gift and a curse. We've got an information overload and a whole bunch of PhDs looking at little teeny tiny corners of teeny tiny cellular mechanisms.
Yeah. I'd be really interested. So we haven't been able to dig up anyone doing pathology on CVD or MI, especially with all these. Like, the more you look into it, the more that it appears we don't know about MI in particular, understanding the possibility that the autonomic nervous system and the immune system is probably much more deeply intertwined with this than we probably thought when the last pathologists were actually digging into this problem. I don't know if you have any thoughts about that, or
you mean CVD pathology?
Yeah, from what I understand,
we can be quite confident up to the adipose dysfunction level. So if you go only up to the adipose dysfunction and not go into what causes adipose dysfunction, because then opinions will differ greatly. So most people will say that you overload your adipose tissue, and that's the main problem. I don't know, But downstream from the adipose dysfunction, I think it's rather straightforward by now.
Mm-hmm.
So what happens is you have these constant cytokine leaking or dumping from these angry fat cells, especially in these different visceral depots like pericardial, perivascular, and then the abdominal visceral depots. And the causal factors for those are rather clear, I believe.
Mm-hmm.
Upstream of that, that's a more interesting and a much more open discussion. What should cause adipose dysfunction and this alteration towards visceral deposition? Whether the personal fat threshold, we even these days things are being discovered, like it's not the actual lipids within cells within a tissue, but there are actual adipocytes. For example, within the pancreas, you have a kind of a pancreatic adipose tissue, fat cells within the pancreas, or the same goes for intramuscular. It's not the intramuscular lipids, but the intramuscular fat cells what can do the damage. So that's why there are some controversies or paradoxes when you have elite runners and they have much higher intracellular lipid levels than normal folks, and they are metabolically very healthy. And the difference is that their lipids are stored in muscle cells and not in fat cells within the muscle tissue. So I think there are still some really interesting things to discover ahead of us. So that's why I'm looking at the incoming research always with a curiosity, that hoping to find something really interesting in today's or tomorrow's news feed. And if I find something, I share on Twitter. And some people recognize if it's important. Other people find it's in Chinese and ask what does that mean. When you grab the really essence of a study, which is the easiest to understand part from that paper, and then somebody comes around and asks, what does that mean? And Twitter is not really the kind of media where you can go into an hour lecture and tell the basics of immunology or whatever. So that's great. These things. It's probably impolite not to answer these questions, but I don't have the capacity anymore to just tell. I don't want to deter them from following me, but so I don't just go and tell them that, come on, you should read the stuff again, because probably he did, but he couldn't comprehend what it tells. But I don't have the time to go and find even easier language, especially in English. It's not my mother tongue.
Well, maybe with our podcast, we can try and give some background to some of this stuff that we can help people get up to speed on it.
If they want to take the time.
I just joke away. I tell them that I find it easier to understand the language in the papers than common basic colloquial everyday English. So if they find it too difficult, I cannot help them, because I don't actually speak colloquial English. So it's just the problem of the paper, the language of the paper, not mine.
Yeah. All right.
Cool. Well, thank you very much for your time. It was awesome chatting to you. Maybe we'll do it again.
It was very nice chat. Thanks for inviting. And yeah, if you have this kind of idea to discuss specific papers, not very frequently, but 1 to 2 times a month, that could be done, I think. Cool. That's always interesting to get the other perspective from people, because otherwise you can just get into your own bubble and your own what is it called? What chamber?
Echo chamber.
Echo chamber, yeah.
Yep. Yeah. You're the easiest person to fool.
Yes, you can always find. I have some kind of a gift. Perhaps I can think differently to other people. I don't know why, but that's a gift one day, and that's a curse on other days. And when you deal with more everyday stuff and you still think differently, that's not always a benefit.
Yeah, fair enough.
Yeah.
Cool. Well, thank you very much, and we'll let you go.
Yeah, have a nice day. And
Thanks. You too.
You as well. Thank you.
See you on Twitter.
Yep.
Will do. Bye.
Bye-bye.